One of the most common uses of Curry 7 is to create averaged evoked responses from continuous data. And what I want to show you here is how fast you can do this in Curry, as well as a lot of the flexibility that you'll encounter along the way. So here we have a data file, and if we look through it just briefly, we see that there are a couple of things going on. There's a large artifact that occurs periodically, and then we have blinks that occur sporadically throughout the file. Now, in this recording, if you look at the bottom, you see all of these hash marks. These indicate the presence of events throughout the data file, and we have type 1s and type 2s. The type 1s, think of this as a visual P300. So the type 1s are the oddballs, and type 2s are the frequently occurring events. Alright, so let me show you just how fast you can prepare the file and then get to the average. First thing I'm going to do is invert the polarity, because I like positive going up. I'm going to change the reference from a common average to the original reference, so this is as the data were recorded. I'm going to filter the file, so it's now been filtered from 1 to 30 Hertz. And now when I look at it, we can see that the artifact, the filtered artifact, has changed somewhat. So I want to reject the sections that contain the artifact, and I want to reduce the blank artifact. I could go through and mark each of these individually and call them bad blocks, or I can do this automatically. So I'm going to do it automatically. So I'm going to reset this, and then I'm just going to go to artifact reduction, and for the first sequence, I'm just going to set it for bad blocks. And it's mainly the P3 channel that's causing the problem, and I'm just going to change it to plus or minus 500. So that'll get rid of the artifact. Then we go to the next sequence, and I'm going to use that to get rid of the blinks. And I'm just doing this quickly just to show you how fast you can do it. And we'll get rid of the blinks. Let me bring these over a little bit closer. So this is with the blink in, and this is using PCA to take the blinks out, using just the first component, and we're using just the data within each of these yellow intervals for the PCA. Alright, now I'm just going to scan the data real quick, and this will scan through and reject the bad blocks, scan through a second time, and get rid of the blinks. So now the data have been corrected, and we'll go ahead and create the averages. So to do that, I'll just go to what we call the event list, and you can create up to 10 averages at one time. These can be single events or multiple events in each case. So for the first group, I'm just going to select the type 1s, and I'll call these the rares. And for the second group, I'll select just the type 2s, and we'll call these the frequent. And let's go back to the first ones. Sometimes just by chance you get 2 1s in a row, and in this case I don't want to use the second one. I want to use only the number 1s that do not have a 1 coming after it. And so I can do that by going to conditions, and I'll add a condition, and I want to say that for any event that I'm looking at, any type 1 event, I want to make sure the one before it is not a type 1. And if that's the case, then we'll add that to the average. So I'll say OK. So we've added conditions on top of this first one now. Okay, I want to create epochs from -200 to 800 milliseconds, and we're going to use noise statistics. And what this is a way of deciding whether to include or exclude the individual epochs based on the signal to noise ratio. And for this, I'm going to use all of the channels, and I'm going to define noise as the time range, the pre-stimulus time range, and I'm going to define the signal time range. I'm going to decrease this somewhat, and now I'll just scan through it, and here are the results, and here are the minimum and maximum thresholds that have been set automatically. And this is showing the SNR for each epoch going through the file. And if you go through and look at these, which you can do just by double clicking, they're all good epochs. But I'm going to take these out anyway just to show you what it looks like. So now I'm using very stringent criteria. And if we go back down here, you can see that there are 193 that are accepted. And if we apply these criteria, it drops it down to 171. And so if we did averaging right now, we would use just these 171. Okay, I'm going to take reject off because I'm going to use all of them because basically they're all good. And now we have a choice to make. Do we want to create the averages all at one time, or do we want to save the individual epochs and then create the averages? Well, let's do both. So first we'll create the averages all at once. And here's the average of the type 1s, which I'll display as a butterfly plot. This just superimposes all the channels on top of each other. And here is the average of the type 2s. Okay, so type 1s, type 2s. If we want to take the difference between them, we can go over here to epochs and averaging and just take difference. Now we're looking at the difference between the two, and if we want to pick the part where P300 is probably occurring, and if we want to look at maps for that, this is what the distribution looks like right around that particular peak. So that's how fast you can get to the averages, and of course now you can save them. If you want to save the individual averages or the difference, or you can save the files and have them. Up to this point, we haven't saved anything yet. Everything has been done in place with the original data file. Alright, now I'm going to revert back to the continuous data. And this time, instead of going directly to the averages, we're going to save the epochs as a separate file. So the first thing it asks me is what I want to call them, and I'm just going to change to a different folder. And I'm going to call it just epochs. And I want to add this to the database. So I'm creating a subfolder called epochs, and we're going to open it automatically after it's been created. And now we've got the individual epochs, which I'll again show as a butterfly plot. And to give a little more room, I'm going to take off the mean global field power. And so now we can go through and look at individual epochs. And actually they all look very good. I mean, there's nothing in here to reject. But if we want to reject things, we could. So let me just show you how that works very quickly. If we want to reject on the basis of voltage thresholds, we can do that. So let's change it to something low enough where we'll pick up some quote bad ones. And let's just use all the channels. Here we can do noise statistics again. I'll go ahead and set them the way that I did previously. And you'll see these numbers change based on the A to D rate that was used. Okay, and now we'll just scan. Nothing has been applied at this point. All we're doing is just scanning with these criteria and collecting the results. Now if we want to look at the results, we can look at just the voltage. And here's what plus or minus 30 looks like. And you can see it's rejecting a few sweeps. So we'll say we'll leave that. If we want to look at just noise, so now we're looking at just the pre-stimulus interval. And we'll go ahead and change these to make it a little more stringent. And if we want to look at the SNRs, we can do that. And I'll also adjust this a little bit, just so we have some to throw out. Basically, these are all good, but I'm just showing you what it looks like if there were bad ones. And now, we haven't rejected anything yet, but if we apply the voltage criteria that we set, we see that it drops from 193 down to 165, or we can apply just noise, or we can apply just the SNRs, or we can do any combination of that. So let's say we do SNR and voltage criteria. Now we'll go back up, and if we want to average just the rare ones, okay, we select just the rares and then average, and this is again what it looks like, just like it did in the instant average. And here's what the average of the frequent looks like. And of course you can then save these. What I wanted to show you in this quick demonstration was how fast you can process the data in Curry, and to give you an idea of the flexibility that you encounter along the way.